All right, so get ready because today we're going way back in time to ancient Greece. We're diving into On the Gait of Animals by Aristotle.
Oh, Aristotle.
Yeah, I know. You might be thinking, philosophy lecture. Really? But hold on. This deep dive, I promise, is different. We're talking about how animals move, like literally how and why. And Aristotle's take is, well, it's surprisingly relatable, even kind of funny sometimes.
Yeah, it really is a fascinating look at how, a brilliant mind like that tackled such a basic question about the world around us, right? How do things move? And it's amazing, some of his observations, they still hold up even today.
It's true. It's true. It's like you're peeking right into the mind of like a scientific OG, a
Yeah.
pioneer. One thing that really stuck out to me was his idea that nature doesn't just like do things randomly. There's a purpose to everything.
Exactly. It's like almost like he had this early version of evolutionary theory, right?
Right.
Yeah, he was convinced that every single little detail of an animal, from its limbs, its wings, everything, it's all designed for a specific reason. It's for that animal's way of life.
So like nature's a really good engineer, no wasted effort,
Right.
which leads him to some pretty interesting conclusions. Like, okay, why snakes don't have legs?
Right.
Of all the things, right? Why no legs?
He argues that to move, you need at least 2 points of contact. One point to push off from and another point that's being pushed against. He called these the minimum points of motion, and he uses this to explain, well, everything. Walking, jumping, even how snakes slither.
Okay, yeah, I think I get that. So like when I walk my foot on the ground, that's the pushing point, and then my hip that's being pushed forward, right?
Exactly.
But how does that work for a snake? They don't have legs to push with.
Well, think about it this way. A snake uses the curves of its body as its points of motion. It's pushing against the ground with those curves to basically propel itself forward.
That's pretty slick. It's kind of like, you ever notice how sometimes, well, tall people, like me, we kind of have to sway a little bit when we walk just to stay balanced?
Oh, yeah, yeah.
Aristotle, he compares that to how snakes move.
He does. He really does. And that just shows, like, his incredible attention to detail, right? And his ability to connect these things that seem totally unrelated.
Right.
But there's more to this whole points of motion thing. He also believed that animals with blood systems, like us,
Yeah.
we can only have up to 4 points of motion. So basically 4 legs max.
Interesting. Why four, though? Did he just, like, look around and see that most animals had that many?
He went a little deeper than that, actually. He noticed that creatures that had too many body parts, well, they were more vulnerable.
Yeah.
Like, imagine if you chopped an animal in half. Not exactly a recipe for survival, right?
Yeah, great.
But insects, they're different. They've got all those segments, and even if you divide them, a lot of times they can still survive.
Huh. So 4 limbs, it's like this perfect balance between being able to move around and not, dying if you lose a part.
Right.
Makes you wonder if that's why so many creatures ended up with that, 4 legs.
It's definitely a thought-provoking idea. And this focus on limbs, it leads us to something else pretty interesting. The whole idea of right and left in movement. Aristotle noticed that for animals with limbs, well, movement usually starts on the right side.
Really? But aren't there left-handed people? And animals, too. Did he ever talk about that?
Well, his main focus was on the right side. He saw it as the one that kind of kicks off the movement. He even noticed that humans, we tend to carry things on our left shoulder so that our right side is free, And get this, even those spiral-shelled creatures.
Oh, like snails.
Yeah, like snails. They favor the right, too. They turn in the opposite direction of their shell. It's pretty wild.
That's some serious attention to detail, I gotta say. So, okay, back to snakes for a second. If having 4 limbs is so important, how come snakes don't have any? Like, they're totally missing out.
Aristotle figured that their bodies, being all long and narrow, well, limbs just wouldn't work well for them. He saw their slithering as like their own version of 4-point motion. Like each curve of their body is kind of acting like a point of contact.
So they're not really limbless, they just, like, adapted their whole body to be the limb?
Yeah, pretty much.
That's wild. Didn't he also say something about bending being super important for movement, too?
Oh, absolutely. He called it flexion, and he argued that it was essential. Walking, swimming, even flying. Think about it. Even when you're just crawling, you're bending your arms and legs.
Yeah, actually, when you watch like a cheetah running in slow motion, you can really see how those legs bend and extend. It's incredible.
He was definitely onto something there, even without, slow motion replays. And speaking of different ways of moving, let's think about birds and humans. We both walk on two legs, but our bodies are built so differently.
Oh, yeah. Yeah, I remember once I was trying to walk like a pigeon,
Mhm.
and, well, it just didn't work. It made me realize how different our bodies really are, even though we're both bipedal, you know?
That's a great point. And Aristotle, he picked up on that difference too. He points out that humans are, we're truly erect with lighter upper bodies and heavier legs. Birds, on the other hand, they're kind of hunchbacked with those powerful hips and a backwards weight distribution. He actually compares them to bronze horses with prancing forelegs.
Okay, now I can totally picture that. And it really shows you how form and function go hand in hand in the animal kingdom, right? It's like
Mm.
every animal is a perfectly made machine, perfectly designed for, its specific environment.
Exactly. And he gives all sorts of examples, like how birds have those oblique wings,
Mm.
powerful flight, and short back set legs that are perfect for swimming.
It's interesting. What about those animals that live underground in burrows and things? I bet they have special limbs too, right?
He talks about that too. He describes how their limbs are all splayed out, which helps them creep around and even sit comfortably on their eggs. And then of course there are crabs with their sideways walk and all those leading legs.
Speaking of crabs, they always seem to break all the rules with that sideways shuffle. I wonder what Aristotle made of them.
Crabs were a fascinating case for him. He thought that their unique gait was because of their hard shells and because they don't have a tail, almost like they were forced to adapt to a less than ideal situation.
It's amazing how he connected all these seemingly random observations into this whole understanding of how animals move. It's pretty impressive. There is one group of animals that just throws a wrench into his whole system, though. Mollusks.
Ah, yes, mollusks. They definitely gave Aristotle a run for his money. They don't have a clear right and left side, so he saw them as, well, mutilated, moving contrary to nature.
That's kind of harsh, isn't it? Like he just couldn't quite figure them out. So what do we know about them today? How do they move without a clear right or left?
That's a question we're going to dig into a little deeper in our deep dive. Mollusks are a truly diverse group, and their movement, well, it's anything but straightforward.
Okay, you've got me hooked. Let's unpack these mollusks and see how they fit into Aristotle's grand scheme of animal motion, or maybe how they don't fit. Okay, so mollusks, these are the creatures that, like, really stumped Aristotle. It's like they broke his system.
They did. They really did. And you know what's so fascinating? It's that broken system that makes them so interesting. They really make us question those ideas we have about symmetry and appreciate just how diverse life on Earth really is.
It's like nature's showing off a bit, saying, look, I can do things your way, but I can also do something totally different, and it's just as cool. So, like, how do scientists today explain how these rule breakers move?
Well, first we have to remember mollusks, that's a huge category, right? We're talking about everything from snails and slugs, those slow-moving guys, to like octopuses. They're incredibly agile. So there's a whole range of movement styles within this one group.
So no one answer fits all when it comes to mollusks.
Yeah, pretty much. But there are some common threads. Lots of mollusks, like those snails, they move using this muscular foot. It kind of ripples and contracts, almost like waves to push them forward.
So it's more of a gliding motion than actually walking. I'm
Yeah.
picturing a snail leaving a tiny little wake behind it.
That's a great way to put it. And that wave-like motion, it's really efficient, especially for creatures that, well, aren't in any rush.
Makes sense. But then you have those cephalopods, like octopuses. I mean, they seem to break all the rules. They're so flexible, so fast. Remember that video? Went viral a few years back. The octopus squeezing through that tiny hole in the boat.
Yeah.
Mind-blowing.
Cephalopods, they're in a league of their own. They've got these complex nervous systems and incredibly precise muscle control. So they can crawl, swim, even like jet propel themselves through the water using a siphon.
It's almost like they've got this like separate intelligence just for movement.
Yeah.
Did Aristotle even have a chance to, really see these creatures in action?
He probably saw some cephalopods back in the day, but he wouldn't have had the tools or the knowledge to really understand how they moved.
It makes you wonder what he would have thought if he could see them, in those high-definition slow-motion videos we have now, watching them change color, change shape, just gliding through the water. Would he have been able to fit that into his ideas about animal motion?
It's tough to say, but I think it would have definitely made him rethink some things. Mollusks, those cephalopods especially, they show us that there are always exceptions. And that's part of what makes studying nature so amazing.
So mollusks, they might have messed with Aristotle's theories a bit, but they also opened up this whole new world to explore, They remind us that nature is full of surprises and that even the smartest people can be, challenged by new discoveries.
Exactly. And while mollusks might not fit perfectly into Aristotle's framework, they don't disprove everything he said. His ideas about, the importance of bending, the connection between how a limb is placed and how an animal lives its life, those are still really valuable for understanding a lot of the animal kingdom.
It's a good reminder that science is all about building on what we know, right? We're always learning and changing our understanding based on new things we see.
Absolutely. And speaking of learning and adapting, let's move on to something else Aristotle talked about. It's the connection between an animal's anatomy, how its body is built and how it lives its life. He was convinced that every feature served a specific purpose, like form follows function in the animal kingdom.
Yeah, it's like each animal is this perfectly made tool, like it's designed for its specific job.
Yeah.
It's a pretty cool way to think about why we see so much diversity in nature.
It really is. And Aristotle's way of looking at things, just carefully observing and asking questions, it can still teach us so much. Even after all these centuries, he didn't have all the fancy technology we have now, but his method, his approach to nature, it's timeless.
Makes you wonder what he would have thought if he could see the world through, our eyes. Imagine showing him a hummingbird's wings in slow motion, or like the inner workings of an ant colony up close.
Oh, he would have been amazed. But I think he would have been even more excited about all the new questions those images would bring up. Because that's what science is all about, right? It's that constant search for understanding.
And that's something we can all learn from, no matter who we are or what we do. That curiosity, that willingness to just look closer, to ask why. That's where it all starts.
I completely agree. And who knows, maybe hundreds of years from now, someone will be looking back at what we're doing and they'll be amazed by what we've discovered. Or maybe they'll laugh at some of the things we got wrong, just like we sometimes laugh at Aristotle's ideas that didn't quite, hold up over time.
That's a pretty humbling thought. But it's exciting too, right? It's like this reminder that knowledge is always changing, always growing. And we can all be part of that.
Well said. And I think that's a good place to wrap up our deep dive into Aristotle's On the Gait of Animals. Hopefully it's inspired you to look at the natural world with a little more, wonder and curiosity.
Thanks for joining us on this trip back to ancient Greece. Until next time, keep those minds curious and never stop exploring.